Hello everyone, and welcome. Hadoop and its ecosystem has become increasingly important to businesses of every type. Hadoop holds the promise that it will unlock the value of your data and give you the insights that will help you flourish your business. Now, you're here, so maybe you're aware of, or you personally experienced, that the overheads of managing Hadoop infrastructures are not so small. As the number and sophistication of the workloads we run increases, so does the operational overhead of our clusters too. This increase in the overhead undermines the core value proposition that Hadoop brings to the table. Essentially, it takes away focus from the data onto how to run the cluster. This is where Google Cloud Platform and Cloud Dataproc come in. My name is Jelena Pjesivac-Grbovic. I'm tech lead and manager at Google. And today, we will see how your migration to cloud and the incremental changes to the way you run your Hadoop and Spark workloads can let you preserve the power of the open source system that you built and reduce the operational complexity, allowing you to refocus on the data. This is a journey. Migration to the cloud doesn't have a one way that works for everyone. There are many valid paths to take. We will highlight some overarching guidelines and the principles and identify useful building blocks that will make the migration to cloud easier and smoother and allow you to benefit earlier from the new stack. So let's begin with what is Google Cloud Dataproc. Google Cloud Dataproc is managed Hadoop and Spark service. Its goal is to help you refocus your efforts to your data instead of managing the cluster. Dataproc achieves this by being fast, easy, and cost-effective. What do I mean by that? Imagine a new version of Hadoop is coming out. It promises to make your critical workload 10 times faster. Sounds great, right? What would it take for you to deploy this new version of Hadoop in your data center? Think of the testing, validation, qualification, and everything else. With Dataproc, this would be one-line command, or alternatively, a few clicks. About 90 seconds after that command line, you would have a brand new data cluster with the version that you want, and you would be ready to canary your workloads even at the production scale. The speed and simplicity at which you can run, at which you can run and start the clusters lends itself to cost effectiveness because you can run the cluster and the resources only when you need them. There's a whole spectrum of approaches on running Hadoop on GCP. Starting with an on-premise, right? We can have any of these options there. And where you're on the spectrum depends on whether you treat GCP as infrastructure as a service or as a platform as a service. Along this spectrum, GCP works with many partners that will help you migration, and you don't have to be alone on this path. So let's look at what how the Dataproc works and how is it built. Dataproc layers the features on top of the standard Hadoop stack. Between the Hadoop's layers, we insert the monitoring, statuses, configuration options, things like that, that augment the Hadoop stack and make it more manageable. We built our functionality using native open source APIs, which means that whatever you did for your own customization in your own cluster will work in Dataproc. Right? You will have a full power how you access these clusters. You can use your standard APIs that you're used to, like Hadoop command line, SSH to the master, or you can use our REST APIs and our UI, third-party tools that we are integrated with. It's your choice. Our distro is based on the Big Top, and it comes with a Hadoop, Spark, Hive, and Pig by default. They are enabled immediately. We provide you with the ability to enable Tez, Zeppelin, and Kafka via something we call the initialization actions. So imagine you're in a place where you are enticed with a cloud and you want to try it out. So what should be your next step? You should be planning your proof of concept, POC. During the POC, you will have to think about what will you take to move your on-premise solution to the cloud. You will think about mechanics, how can I do this? But we encourage you to think bigger. You should think about the opportunities to simplify your stack as well. And as you proceed with POC, this design is going to be really important. Concretely, on thinking the bigger, in your on-premise setup, Hadoop clusters are likely the core of your data platform. In cloud, they're just one of the building blocks. And you can have many building blocks and many different building blocks. Example of the building blocks we'll mention today, and you probably heard today also things like GCS, BigQuery, Bigtable, PubSub, Dataflow, Stackdriver, machine learning, right? All of these can eventually become parts of your platform that's maybe just starting with the Dataproc and Hadoop, right? So when you think of migration, you should lift your platform, and you should leverage these things as well. When starting the POC, you need to identify your high-level goals for the migration, and you want them to be clear and well understood. Some of the goals are on here, like cost savings. What does the cost saving mean to you? Is it the total cost of ownership? Or it is the cost-performance balance, right? Like you want more performance for the same amount of money. What you do, depending on which of these two goals you care about more, it will depend on which of these two goals you actually have. You have concerns about the scaling elasticity. Do you want to solve that problem by having multiple clusters? Or you'll go a step further and you'll disaggregate your storage and compute, and then you can have as many clusters as you want, and you can even throw different tools on your data, right? Development agility, like how do you handle versioning? Do you care about heterogeneous dependencies, and etc. You don't have to, when you think of these goals, you don't have to make significant changes to your stack, but you want to consciously think of the goals you have and do the analysis of concretely do the analysis of the cost and benefits of keeping something the same or trying to change it in the process. So we now have goals, which is great, but we have to understand our requirements, right? The characteristics of your current solution, existing system, and also the timeline that you have in mind for this migration. To get to the requirements, you should look at the tools that you're currently using. What are the components? What are the components you actually want to keep? Because some of the components are really the requirement, and some of the components you added because you had to. It was a hack around the problem you had, right? So perhaps that hack doesn't have to go with you to the cloud. Maybe there is a better solution there, right? Think about the capacity planning. You're going to use the Dataproc, so you're still responsible for sizing your clusters, right? So think about, how much compute you need, what are the average peak, and what is the peak, and what's average data throughputs that you want to support. Think of the security models. And finally, thinking of the timeline is important because depending on the duration of migration that you have in mind, you may have to build a hybrid infrastructure that will host both your current on-prem thing and the cloud cluster. Okay? Okay, so we talked about the planning. You've done your planning. You have your goals. What is the first step? The first step will be the data migration. So usually, when you're thinking of data migration, you look at your storage options and the types of data you have. At Cloud, at GCP, we have quite a few storage solutions. The standard one is Google Cloud Storage, which is our large-scale object store that is accessible through file-based API. We also give you two flavors of HDFS, one based on the persistent disks and one on the local SSDs. Then, if you use Hive, we have a cloud bigtable, right? And we have BigQuery. We also have Spanner and many other products that could meet your needs, right? So you should evaluate them, understand what our benefits and drawbacks are, and then you should look at your data. And usually, one of the first data sets that moves to the cloud is archival and cold data. The stuff you have to take care of, but you don't really use, right? So that's usually the first thing that moves to the cloud. And then you start moving parts of the live hot data, and you start computing with it, right? You do want to, one thing that's important is how you access the data. So to choose which storage option you want, you really want to think of whether the data set requires random access or not. Okay? So again, the first movers, yeah. And one thing to think about is, like, if you have to have a hybrid architecture, you need to figure out the solution that will allow you to keep the same data set in two places. And the partners are really helpful with that. Okay. Okay, so GCS is usually the first GCP solution you will use. So I would like to call out some differences between GCP and HDFS. I'm assuming you're familiar with the HDFS. So GCP is our object store. And for most part, you can use it as a drop-in replacement for HDFS. It has a Hadoop file system interface, all your I/O connectors based, file input/output formats, Spark context, text file, etc., just work. Nice thing with our GCS connector is also that you can install it on your own on-premise cluster. With GCS, you will get a cleaner architecture. Why? Because the data will live outside of your cluster. It will live in our distributed storage that is replicated across the zones, perhaps multi-regional even if that's how you want it. And you can throw any compute on it. You're not limited to just the compute that you have in your cluster, right? Another nice thing of the GCS is that there is no concept of a name node. So if you ever experience scalability issues in your clusters due to name node performance, this does not exist, right? Like, there is no such thing here. And you also no longer have a single point of failure, right? To optimize GCS performance, conveniently, you use the same approaches like you optimize HDFS. So you want to optimize for bulk and parallel operations, okay? So the pros of GCS are high throughput, no scaling bottlenecks, no single point of failure, and the data can be durable across the zones and regions, right? There are some drawbacks. With the fact that there is no name node and that you're across the zones and regions, your latency can go up. Directories in GCS are simulated. So if your application relies on checking a timestamp of a directory, there is no such thing, okay? So you either have to modify the application or you have to use HDFS, right? And objects on GCS cannot be appended once they're closed. So these are sort of things to think about when you want to move the data sets to GCS, right? So, okay, we want to move the data sets. What approaches can we take? Well, we can push it or we can pull it, right? Like, those are two generally approaches you can do. Push approach is, I'm in my on-prem cluster. I connect to the GCS via GCS APIs, and I copy the data from my cluster to GCS, right? It's simple. It has a straightforward security model. Your data is encrypted with SSL, and it goes through internet gateways like this. So you're on your on-prem cluster, and you send your data to GCS, okay? So that's the simplest model. The downside of this model is that you're using your compute on-prem cluster to move the data. So if you were resource constrained on your cluster, this is sort of a set, you're using more resources, right? Alternative model is a pull model. So in a pull model, I set up the VPN such that my cloud cluster can access the data on my on-premise cluster. You really want to do this carefully, okay? And from there, you use the compute in your cloud to just pull the data from your on-prem cluster. From there, the data can go either on your HDFS in the cloud, or to storage, or to BigQuery. It doesn't matter, right? All of these are options. The main difference is in the security model, in the pull approach, your security relies on you setting up the VPN properly and ensuring that you can set up the permissions such that only you can access that data. Okay? So let's take a look at some of the cloud-native architectural concepts. On your on-prem cluster, the data locality was premium. And essentially, you were computing over the data that existed in your cluster, right? That was done for performance reasons and convenience reasons, because usually, when you decided you needed a petabyte of storage, you bought a cluster that had a petabyte of storage. And it came with some CPUs, right? Your computations come and go in a cluster, but your data sits there. So the computation and the data have a very different lifespans for most part. So why not just separate them, right? Why do we have to tie the computation to the lifespan of the data, right? And the process of disaggregation of storage and compute is essentially separating data plane from the computing, right? We essentially pull out the data from the machines. So if this is our cluster, we no longer keep a data inside a cluster, but we use GCS, BigQuery, Bigtable, Spanner, whichever data store you chose. And our clusters are there for computing. And when we're done computing, maybe we can get rid of them. Okay. At the same time, we also, our clusters will produce some data, such as monitoring data and logging data and stuff like that. And that will also live outside of the cluster. It will come out of it, right? Because we don't want to keep this information is useful even when the computation is done. So we separate it from the computation. Okay. Yeah. So this gives you quite a bit of flexibility on how you manage cluster lifespan. But another thing that it gives you also is ability to burst in cloud. What do I mean by that? In cloud, a task that will take 1,000 CPU hours will cost the same if it runs on 1,000 machines for 1 hour or on 10 machines for 100 hours, right? Like the math adds up, right? Like the CPU usage, disk usage, RAM usage adds up, right? But it's very likely that that value is way more valuable to you if you waited 1 hour for it as opposed to 100 hours, right? Now, if your data was confined on the machines that are computing, the chances of you being able to throw 1,000 machines on it trivially is low. But if you store it on something that's highly scalable, like GCS, you can actually throw this many resources on it and compute this much faster for the same price. Okay. Another thing that's feature of Dataproc, and it's used in GCP, are preemptable VMs. Preemptable VMs are regular VMs, but Google reclaims the right. Google keeps the right to reclaim them as needed, so they can come and go. Usually, they're there. Because of this, they cost only 20% of the cost of the VM, right? So they're significantly cheaper than the regular VM, and they're sort of guaranteed to be preempted at least once a day. Okay. So with Dataproc, if you didn't have a Dataproc, you would have to deal with these machines coming and going, right? You want your cluster with 100 machines. You have 95 now because 5 of them were preempted. You have to find another 5, right? With Dataproc, this is managed for you automatically. So you can have your Dataproc cluster with the preemptable VMs costing 1/5 of the compute that you would have with the Dataproc cluster with the regular VMs. Okay? And another thing where this is really useful is if you separated your storage from the compute, the preemptable VMs don't really cost you any loss. Like, they just come and go, right? Different computations have a different resource requirements. So let's imagine that our workload requires 6 CPUs and 8 gigs of RAM. In Google, we have a standard instances, and one is N1 standard 4, which comes with the 4 CPUs and 4 gigs of RAM. There is N1 high mem, which comes with 4 CPUs and 8 gigs of RAM. And we have N1 standard 8, which has 8 CPUs and 1, 2, 3, 4, 5, 6, 7, 8 gigs of RAM, right? But we need 6 CPUs and 8 gigs of RAM. So you can create your Dataproc cluster using custom VMs, which will have 6 CPUs and whatever RAM you need there. I guess these are 4 gig chips. Let's assume 8, right? So depending on computation you want to do, you can actually make a VMs fit the size of your computation and just run a Dataproc cluster with it. These custom VMs came out in March and are pretty neat technological improvement. You don't have to do any bin packing of your workloads. So now we've seen, we separated our data from computation. We understand that we can have a different size machines. So let's take this idea further, right? We can right-size our clusters based on the use case we have. Think of the different workloads you do. You have a MapReduce ETL, you have some machine learning, you do some Hive analytics, and you do business reporting. Do all these workloads need the same computational power? Are some of them more valuable than others, and you're willing to pay more for those VMs so the things would finish faster? So if you were willing to pay for business reporting to use these high-performance VMs, are you willing to spend them on MapReduce ETL? Perhaps, perhaps not. So if you think of this cluster as a building block, you can understand that here you have actually potential for having 4 different shaped and building blocks, right? So we can have 4 clusters with the VMs that look significantly different, have a different price performance label attached to them, and we can optimize for cost, we can optimize for speed, and for different use case, we can choose the right equation, right? So this is right-sizing clusters per use case, right? But we can take it one step further. Okay? So we can have a thermal and semi-long-lived clusters. So at the beginning, I said it takes us around 90 seconds to start the Dataproc cluster, and we'll demo that soon. So this is pretty immediate, right? So we can choose the lifetime of the cluster according to the workload it runs. On one end of the spectrum are ephemeral clusters. Those are clusters that you start to do this computation, and then when the computation is done, you just delete them. As simple as that. I know one of our partners does exactly that. They have some custom-made Spark thing that they run every night. And it's pretty significant. It uses like around 1,000 cores or something. So every night at midnight, they spin up 1,000-core Dataproc cluster, run the computation, and tear it down. Okay? And then midnight next following night, they do the same, right? It's all automatable. The other thing that's nice, if you treat the cluster per computation, like in this ephemeral mode, is imagine you have to change a region for whatever reason, right? It's essentially, all you have to do in that case is like, well, start a cluster in this region and run jobs there. It's as simple as that. On the other end of the spectrum, you'll have these semi-long-lived clusters, right? And even for them, they may end up having some data there. Maybe you're running your own Hive instance or something, so you really need them there all the time, right? Like, they cannot really go away easily. Coming back to one of the use cases at the beginning, like, what does it take to install the new version, right? Well, again, a few clicks of a button and selecting the preview image for the latest and the greatest. And you start a new cluster. You can start debugging on it. You can start load testing and everything else. And once you're happy, just migrate all your workflows to this new cluster and shut down the other one, right? So ephemeral clusters allow you to really treat computation very differently than you did on-prem, but they are not required. It is something that can be done for, if it makes your life simpler. If it doesn't, just go ahead and use the semi-long-lived clusters and benefit from our ability to start the clusters quickly when you want to test the new versions. Okay? OK, so we settled on a couple of architectural choices. How do we actually manage our cluster in our jobs? So Dataproc exposes REST API. And this standard REST API allows you to manage cluster, jobs, and operations on the clusters. And we integrate with many third-party tools like MRJob, Luigi, I don't know which ones, that all allow us, that allow you to sort of handle your clusters using this API, right? You can also SSH on your master node and use your standard Hadoop and Spark commands that you're used to. But we're going to see how managing Dataproc through these APIs look like. So can I have my computer? OK. So here is the Cloud Platform start page, our console. OK. And we'll go find a Dataproc from here. Dataproc is here. And this is in our demo project. So there are 4 projects right now. 2 of them are in US, and 2 are in Europe in different zones. And I started the Jelena Demo 0, just so I make sure I have 1 cluster running. And my colleagues run the other ones. And we live in a separate worlds, right? Like, I can't affect their production or their demos, and they can't affect mine, which is really nice separation sometimes to have. So I want to create a cluster. And here, we'll click on Create a Cluster. And I'm going to call it, and I'm going to call it 2. And I'm going to run it in Europe, because we are in Europe right now. And I'm just going to minimally configure it. Like, I'm going to reduce the size of the disks. And I mentioned you could try running a new version. And that option exists here. So you can choose the image version. And the preview one is a nightly build. We're not going to do that. We're just going to keep the default. And I'm going to click Create. OK? So here, we see my cluster is starting to being made. And at the same time, we'll do an experiment with a command line, which is here. And this is essentially the command line. We do gcloud Dataproc clusters, create Jelena Demo 1 with the 2 workers. OK? And this starts the operation. So here, you can see 2 clusters being spin up, right? Like these 2. It's readable, right? OK, and let's see how long does it take. While they're spinning up, we can look at them. So here, I already have 2 workers. So this one probably spin up fully. I can easily get some overview on the CPU utilization on what the workers, the jobs are doing. And I can see my configuration at any given time, right? I can check on the jobs, but I didn't run any jobs, so there's nothing there right now. OK? Let's go back to all of them. OK, so Demo 2 started. Demo 1 is still spinning up. Let's check it out. Again, this one also had only 2 instances, and I'm guessing it's essentially done. OK, so let's open another tab, and we'll go back to that one. So now, imagine we want to run a job. OK? And we'll run. I have here some Spark, PySpark, hello world in PySpark. OK? It just starts a PySpark and prints hello and world. Nothing too, too exciting. Perfect for demo. OK, so our cluster started in like 94 seconds. So OK, let's go back here. Let's run this job using our APIs. OK, so it copied the files. It started operation. And this is running on demo 1. So I can check the jobs there. It's running right now. And the really cool thing is that essentially you can get the live stream of the output. In a few seconds, it'll start. You can see it finished its job and then printed out, "Hello world." Now, let's say we wanted to run something slightly bit more complicated, but still demo-worthy. Let's compute the value of pi. Okay, and this one will run another Spark job with 1,000 tasks to complete this. And this guy will run on our demo 2 cluster. Okay. Okay, so you can see small spikes in CPU, the jobs that are running. This one is running. We have our VM instances. Again, if I click here, I can see it executing. And you can see this is the number of tasks. It just started, so it has 0 task, and it completed 0. And I guess the new line is hard to add. So we'll have a little bit of noisy output. But we just computed pi that it's 3.14162. And for everyone who knows that it's like 14159, whatever, we need to recompute it better. Right? Like, this is not good enough. So let's try running a 50 times bigger problem. Okay? So instead of 1,000 tasks, let's do 50,000 tasks. Okay? Yeah, so this job with 1,000 tasks took 33 seconds. We're now running with 50,000 tasks. And maybe we figure out, whoops, this is going to take 50 times 30 seconds. I have like 7 more minutes. Maybe not a good idea. I need more resources. So I'll edit the cluster. And instead of 2, I'll do 100 VMs. OK, and I got quota. This quota. OK, 200 is not going to work. But let's do 40. OK. Maybe I selected the wrong zone. Sorry. Come on. OK, let's run it on the other cluster. Actually, I'm really upset with this cluster, so I'm going to delete it. OK? And that one is going to go away. And I'm just going to kill this guy and go to the beginning of the line and change it into run it on demo 1. And while we are doing this, this cluster is being deleted with all the artifacts that it created. And this one, I'm going to increase the more machines, because in this zone, I know I have quota. Come on. OK, so the quotas are not cooperating with me today. So let's do 30 nodes, although. OK. Thank you. So what does it mean? Let's look at our VMs. Voila. My extra 30 VMs are showing up, and it will take them a few seconds. And this is on my demo 1 cluster. And as they start appearing, you'll see they're faster than the originally. So in a few seconds, they're all here. And now all that has to happen is that my Hadoop cluster picks them up and start sending tasks to them, right? And while the job is running, I want to show you that we allow you to see your standard Hadoop UI, right? Like, if you really, really, really love your Hadoop UI and you know how to debug things on it, we allow you to do so. You just need to set up the VPN. It's a pretty straightforward. It's documented on a page. And on this guy, we can check the nodes. And at this point, it started with 2, but now we have way more nodes, and they're all processing our job. OK, so with this, let's switch back to the slides. OK, so you've seen me use a few ways of accessing REST APIs, some from command line, some from UI. It's integrated with the tools like Luigi and MRJobs, so you can use those tools as well to run the jobs on a Dataproc. There are 3 ways you can actually run the jobs. Like I did not demo the Hadoop one, but essentially on that one, you would just SSH on your master and be able to run like you usually do. You've seen me a few times unsuccessfully resize the cluster, but then I was successful. But the challenge was the quota. I selected the wrong zone. But the point is, like, it was a click away, right? And that's edit and change the number of machines, right? Thing I did not show you all is that these clusters are integrated with Stackdriver. Stackdriver allows you to set up the monitoring and logging. So essentially, all the information gathered about your cluster will be preserved there, and it can be turned into really nice dashboards. It can be set up such that it causes alerts. So if you have someone monitoring your production, they can actually be alerted if things are not going the way they're supposed to. And you'll be able to access your logs even after you delete the cluster. And to put it all together, we initially will probably just start with moving the data away and putting it in a cloud. And then we'll start experimenting with workloads that are maybe bursty or new applications we want to run. As we go along, we may end up building a hybrid infrastructure where you'll host both your on-prem and the GCP clusters. And finally, you might end up in a native cloud state where all your computations, all your data lives in the cloud and operates well with all other building blocks that we have in Google. To start, we have a good documentation on cloudgoogle.com Dataproc. We also have many ways to get help through our documentation, through our release notes, Stack Overflow. We scrub it all every day and make sure we answer the questions. We have email lists that you can send emails to, Google Cloud support, and another one that is not listed here is our partners. So if this looks as a daunting task, you can partner with many good companies that are listed on our website that can help you with this. So with that, I'm happy to take any questions. It seems like the standard way here is to ask questions after the talk. So thank you all for coming.
So it's here I stand as a broken man, but I found my friend.